All right, so here's thermochemistry. Thermochemistry has to do with energy, and energy is the capacity to do work. Work is defined as the measure of energy transfer that occurs when an object is moved over a distance by an external force. All right, so you need these two things to perform work. Two bits of energy that we're going to talk about. One is potential, the other is kinetic energy. Potential energy is the stored energy in an object or system because of its position or configuration. So if this is the ground and you hold up two objects, this object is going to have less potential energy because it's closer to the ground, and this object is going to have more potential energy because it's further from the ground. Some chemicals have more potential energy because maybe they're unstable, and if you ignite them, they explode. Other chemicals have less potential energy because the same thing wouldn't be true for them. All right, so holding a marker up higher gives it more potential energy. Kinetic energy is a form of energy that results from an object's motion. So now it's moving. So if we were to let go of these two little boxes and they were going to start falling towards the ground, that would be its kinetic energy. All right, so dropping the marker converts the potential energy into kinetic energy, since now the marker is actually falling. Virtually every chemical reaction is accompanied by a change in energy. Chemical reactions usually absorb or release energy as heat. Energy is absorbed or released in physical changes as well. So, for example, if you had an ice cube and it absorbed energy. So the ice cube it's a solid, it's water in a solid form. If you were to give it energy, maybe by holding it because you're warmer than the ice cube, it's going to absorb energy from its surroundings, from you. And the ice cube is gaining energy. So this is a endothermic situation or reaction here because it's absorbing that energy. Now, as it absorbs that energy, it will convert that into melting. So it'll start melting if you give it enough energy. We can also look at the opposite, so getting close to fire. All right, so you have wood, it's burning, and in that situation, the fire is giving off heat energy. So if you get close to it, you're going to feel that heat that's given off. So this is an exothermic reaction, all right? And combustion reactions are going to be exothermic. So we have thermochemistry. It's the study of the transfers of energy as heat that accompany a chemical reaction and also physical changes. All right, so that's thermochem. That's this chapter. So we're going to do some numbers with this because we're going to be able to calculate the amount of energy. All right, so next up we have the energy absorbed or released as heat in a chemical or physical change is measured using a calorimeter. All right, now this is kind of like a hydro flask where the external environment is not going to be able to influence the internal environment. So if you, in other words, if you put something cold inside of it, it's going to be like a thermos and keep it cold. It's not going to let the room, which is warmer, warm it up. The opposite's true too. If you put something hot in there, the outside environment's not going to let it cool off. It's going to keep all that energy in there. All right. Now, what your goal would be is to put two things together in the calorimeter and then see how energy is transferred from one object to the other. And we did this in a lab where we had a beaker of boiling water. All right, so there's our boiling water. We put in a piece of metal. If you remember, I think it was brass and aluminum. We let that brass and aluminum heat up so it was 100 degrees. All right, so that piece of metal was 100 degrees. We used tongs, and then we transferred it into the calorimeter, which ours was basically a metal container and then a tiny styrofoam, smaller container inside, like a styrofoam cup. And in that styrofoam cup, if you remember, we measured 100 milliliters of water. We took the temperature of it. All right, it was room temperature. And then we put that hot metal in there, and we measured how much the water temperature changed. It went from something like maybe 20 degrees Celsius up to maybe 24, 25 degrees. The water absorbed energy and the piece of metal lost energy. And then we did a whole calculation on, how much energy was lost. And we're going to get to that calculation later on. All right. So this is kind of what we're talking about here. Okay, so the energy given off during an exothermic reaction is equal to the energy absorbed by the calorimeter. So what we have here is that kind of situation where the metal gave off a certain amount of energy and the water absorbed that energy, and the calorimeter itself just kept everything inside of there, so no energy was kind of lost. All right, so it all stayed within there. We used a thermometer to measure it.